Halo, selamat pagi. Hi everyone, good morning. Hi Richard. Oh, makasih udah. Ada Falco.
Okay, great. So we see a lot of kids joining, right, Miss Asri?
Yes.
Yeah.
I see some familiar faces, Miss. Ada nih, ada Richard. Ada Falco juga.
Ada Bebe juga, Miss.
Oh,
Ignacio,
hi,
Bebe.
Yeah, hi. So while waiting for everybody to go in, why don't we use the chat as well to introduce yourself? Write your name and your city as well as your age. How old are you? We want to know where everybody is from. Because today is very special. We have, from what Miss know, at least we have 3 continents here. We have people from Indonesia, which is Asia. We have people from US, and we have somebody from Australia. So yeah, use the chat to write your name, your age, and your location. And I would like to ask everybody to mute. Okay. And you can use the chat if you have any question, because we're gonna have a lot of things to do. We're gonna listen to 2 great presenter, and then we also going to do some experiment. So make sure you prepare your items, right? You have everything that you need for the experiment. Okay, so quick introduction. My name is Miss Melanie. I am the founder of KodeKiddo. And right now I'm joining you guys from California in USA. Today we have 2 special presenters who's going to tell you some interesting stories about themselves and about science. One is Miss Christo. She is also calling in from US. And the second one is Miss Priscilla, and she's calling from Australia. And as you can see here in the agenda, we are going to do 2 experiments. One is called soap versus virus. And then the second one, this is going to be a treat for you, because after the experiment, you can eat it. We're going to make our own ice cream. Okay. So let's just get started. We will probably spend about maybe 1 hour, 15 minutes, but it will be fun because you guys not just gonna listen, but you also gonna do something. Okay. Okay, so I'm gonna hand it over to Miss Priscilla as the first presenter.
Thank you, Miss Mel.
Yes.
Hi, everyone. My name is Priscilla. So I'm a Master of Electrical Engineering with Business Graduate from the University of Melbourne. Currently, I'm working as an electrical engineer in EXTC. So I'm actually a testing and certification engineer in the hazardous areas. So when I say like hazardous areas, I'm referring to like things like mining and highly explosive areas. So where even the presence of dust, something like flare itself can make such a large explosion. So my job really is to just ensure that these electrical equipments that we use in the hazardous areas are safe to use and follows the government regulations.
Okay, where did you go to school? Where did you learn all about electrical engineering?
So I started off from, so I used to go to high school back in Raffles in Jakarta.
Right?
Yeah. And back then, I really have no idea about electrical engineering. All I know is like watching robot movies and all those normal normal kids things. And then I ended up in Melbourne Uni as an computer science, but then one of my friends actually inspired me to join electrical engineering because he said how we can actually learn more. We got to learn about coding and we learn about math and hardware stuff, how I can actually get to physically touch and play with them. So my first thing that I actually did, my first project as an electrical engineer was making a game console because I love gaming, and there was a project in one of the subject in uni that gets me to make a game console. So I was like, why not? So that actually gets me into electrical
I think everyone here likes gaming and coding. So that's
yeah.
Okay, go ahead.
All right. We might move to the next slide. All right, so I've been talking about my job as an electrical engineer, but how many of you guys actually know what an electrical engineer is and what do we do? So basically an electrical engineer, someone who design and improve electrical equipment. No, we are not PLN or whatever, we are different. So yeah, basically we want to help the world to make it a better place for us to live in. So one of the things that you guys are probably familiar is headphones. We design your headphones, your game consoles, something like drones, cars, robots, many others. So basically all those interesting stuff, we design it. Yeah, we are cool.
Quick question. So you mentioned about that you also learn computer science and coding. So does it have anything to do with this physical items?
Yeah, so things like drones, firstly, you will need to know what kind of drone you're gonna make. Currently, people want to make drones, of course, the one that can fly, stabilize, and bring stuff for them, for example. So that's your objective. And then afterwards, you start designing the electrical parts. But there is also the inside program that you will need to program. So these drones know where to move when you click them. They'll know, oh, all right, I need to fly. I need to go to the left or go to the right, or what do I need to do? So that part you will need to code it despite having all the hardware stuff.
Yeah. So it's a combination between the hardware, but the hardware need to be controlled with the software, right?
Yeah, that's right.
Cool. Mm-hmm.
Okay. Next, so how do we actually design our stuff? So the first step is, as I mentioned earlier, we decide what will the new electronics we want them to do. And then next, after we know what we want to do, for example, we want to design a robot that can help you clean your house, or I don't know, maybe you want to make a dishwasher. Then you design the circuits and you decide what electronic components that you will need to build inside. So for example, there are a lot of types of electronic components, like maybe a switch, batteries, microcontroller. I think in KodeKiddo, we do have the Arduino projects, the school program, was it? So that's one of the electronic components that you can put inside your circuit design. And also we need to think about how and which way we should connect the components. So there's a lot of things going on as you are going to wire them and all. And we need to do all the calculations, decide how much power, current, voltage that we'll need to design these equipments. And so most of the time you also need to program the electronic equipments, like what I said earlier. So for example, your PS console, you know that when you turn it on, it will turn on and then connect to your remote, your TV and whatever it is. So that all runs under a program. So they know what to do when you press a control, basically.
Somebody has a good question here in the chat. According to your experience, Miss Priscilla, is it important student in elementary school in Indonesia learning coding? Give the reason, please.
Yeah, I think currently coding, especially like technology, basically has become like part of our life. So you can look around and see everything is basically made of technology. Even people back then probably do the laundry by hand and everything. Now just chuck it in. We have other better things to do apart from doing those housework. So that's all thanks to the technology. And as you can see, all these technology actually use coding. So definitely, I think in the future, coding is just going to be more and more important. It's probably going to be some important subjects like math, like physics, something that it's a compulsory subject in school as well in the future. All right. I hope that answers your question.
Yes, thank you.
And so next, what we do is we test these equipments that we made. We check if our design is good enough, if was it robust, then whether any improvement is needed. So sometimes, for example, when we start making, for example, my first project on game console, when I first made it, it wasn't perfect. Sometimes when I click the switch, it may turn on or it may act up, like it doesn't want to turn on when I want it to turn on. So we need to keep adjusting. We need to find and debug the problem. And then, because sometimes this equipment that we do can be very complex. It's not like 1+1 kind of thing. And so it's very rarely that whatever you design will work at the first testing. So as an electrical engineer, we need to figure out why it doesn't work and then fix them.
Have you ever get Zep electrocuted by
Oh yeah, I do.
testing?
A few weeks ago, so I was doing this battery short circuit testing at work. And so what happened was I was trying to get onto the end of the battery, but I couldn't find a ceramic knife. So I was actually using a steel knife and I accidentally short circuit the battery and it causes a spark, which we actually don't want. But luckily, we, all measures was fine. We have all the health and safety. So nothing went wrong. The battery didn't explode. So it was kind of lucky.
But that's part of the process, right? Always doing some testing and there's some failure.
Oh yeah,
and
we do a lot of testing. So we actually do want to do that short circuit testing, but not like that, not with accidental move. So we usually put it down in the special box. So it's a box designed for explosion. So because there is a probability that these batteries can explode. So we actually put them inside. So if it does explode, it will not go out of control. But so
yeah.
All right.
Okay.
So let's move on. So why do I choose electrical engineering? I kind of say that partly already, but basically as a kid, I grew up watching a lot of robotics movies. I always hope that one day when I grow up, I will be able to build some cool robots like this, or some, especially like Transformers. So for those of you who love robots, wants to make one for your own, you can become an electrical engineer as well.
Yes. And actually, I'm very happy to have Miss Priscilla and later on Miss Christo as the presenter, because maybe you heard, right? Usually there's less females or girls who goes to study in the STEM area. So we are very fortunate today. Both of our presenters are female. So this is really a role model for you girls, the girls here you should not be afraid. We can be as good as the boys. So, okay, go ahead, Miss Priscilla. Is that all from your side?
Yeah, I think that's all from me.
Okay, good, thank you.
Questions?
Yeah, if you have kids have questions, you can use the chat. In the meantime, since Miss Priscilla mentioned something about circuit, right? Do you remember the picture, the circuit picture? We're gonna talk a little bit about electricity and circuit. And here, instead of me speaking, I want you guys to watch this quick video about electricity. So let me share my computer sound so that you can hear.
Hey, listen to this one. Dear Tim and Moby, when I touched the doorknob this morning, I got a shock. Why? Why? Sincerely, Amos. Why, that's static electricity. Static electricity is the result of tiny subatomic particles called electrons being pulled from one surface to another. This can happen if you take off a sweater too fast. The difference in electrical charge can cause sparks when you touch a metal object. Lightning is a larger version of the same effect, as masses of air rub against rain clouds. Another kind of electricity, electrical current, consists of a flow of electrons through a conductor. The electrical current powers many things in our lives. These appliances all have one thing in common. They all need an electrical circuit to work. An electrical circuit has three parts: an energy source like a battery or a wall socket, an energy receiver like a light bulb, and an energy pathway like a wire. Electricity flows through the circuit, delivering energy to the light bulb. When electricity flows through an object, a magnetic field is created. Magnets have two poles called north and south. Opposite poles attract each other, while similar poles repel each other. The Earth itself is a giant magnet. Charged particles flowing through the liquid iron core give the Earth a huge magnetic field. That's why compasses point north. Electricity helps us in many ways, but it's good to be careful when you're dealing with it. It can be dangerous, and you shouldn't mess with it. Right, Moby? Moby?
Like that. Moby is like Miss Priscilla gets zapped by the electricity. Okay, so anyway, so kids, at the end there will be a fun quiz. So make sure you pay attention. It's just for fun. It's not graded or anything, but I see some in the chat, some kids say they learn about electricity and circuit at school. So that's good. I'm glad your school also introduced you to this kind of stuff. As you hear in the video, right? So electricity needs power source to turn on some light in this example. Now I want to show you one platform that we use in KodeKiddo and Kiddo STEM as well for kids to learn how to create a circuit using virtual. So if, let's say, you don't have all of this equipment, you don't have like the components, physical thing, at least we can try it first using just computer. You just need a laptop and an internet connection, of course, right? This is called Tinkercad. And as you can see here, I'm just gonna do a quick demo. So this is, I have already created this one, one battery, one light, and this is called a resistor. And if I want to test my circuit, of course, first of all, I have to make sure the positive side of the battery connects to the positive side of the light. This light, you can see it's kind of small, but you can see the legs are different. One is kind of bended, it's called anode. This is the positive side that needs to connect to the positive side of the battery. And then this is the negative side. And circuit has to connect, right? Like a circle. So now if I want to test it, I just click start and you can see my light is on. But what if let's say, I didn't connect my wire, or let's say I delete this wire altogether. I start it. Of course, the light won't turn on because now it's not a loop. Now it's not a closed circuit, right? Now, if I want to connect it, I just click here from one side. Oh, I stopped first, sorry. I stopped the simulation. I click one side. This is my wire. Virtually, now I'm connecting it as a loop. I start and it's on again. And it's here very easy. Let's say I don't want my light to be blue. I want different color. I can just change it to red. Okay. Now it's red. Now, if we have time at the end, I will give you the link to this one so you can play around too. But let me ask you as a challenge for now. So this one, as soon as I start it, it's on right away, right? But usually in the real life, we want to be able to have a switch, right? We want to have a switch because we want to be able to turn on and off our light according to our needs. So if we want a switch, we can see here, this is all the components that we can use. And one of it is a switch that's called push button. I can drag it here. Now, I need to move this one instead of directly there. Maybe I'll just create another one. Now I can connect this to my switch. Now if I start the simulation, is it on? It's still not on because the switch is not turned, right? So if I click the switch, now it's on. If I unclick the switch, it's off. If I click it, it's on, right? So this is one good way to learn to make a model or prototype of a real circuit before you actually do the physical stuff. And there is a lot of project we can do here. Some of it using, this is called Microbead, where we can do more complex stuff. We can even code it. We can code like using blocks like this, like Scratch, but now we can code the component. So this one, for example, this is more, this is using like a proximity sensor. So see, if it is too close, it will create a picture of the side, for example. And then if it is maybe, if it is outside, it will do something else, right? So that's just one quick example. I just want to share with you that as part of learning science, in this case, the electricity, we can also do it using virtual circuit. Now, are you ready for first experiment? Yeah. Okay, let me stop my sharing and I'm going to highlight this one. Okay, now you can see the bowl. For this first one, which is soap versus virus, later on, Miss Crystal is going to explain, but let me ask you to prepare, right? You have a bowl, you have some water, and some black pepper. That's all we need for the first one, okay? So, we're gonna pour water in 2 bowls. You can follow along and do it on your side. Not just me, but you also do it. It's super slow, so open it bigger. And if you have questions, you can raise your hand or put in the chat. Miss Ashley can help you to answer it. Okay, so do you have these 2 bowls? Yeah?
Okay. Is everyone follow Miss Melanie? Ada yang kesulitan nggak?
Okay.
You need...
Now,
normal pepper, Miss, not black peppers. Okay.
Yeah, it's okay. It's okay. I use black pepper so that I can see it better. But if you have normal pepper, the white one, it's okay too. So okay. I'm gonna pour a little bit on both of them actually. Not too much, just a little bit so it covers. You can see it kind of like covers the surface of the water. Okay. You got it? So we're gonna do experiment first and then later on we'll see the explanation, okay? So the first bowl, my hand is kind of like dry. I don't have anything on my hand. And if I put my finger inside the water, you see what happened? Like the peppers stick on my finger, right? And my finger becomes dirty because I just put it there in the water with pepper. Now, let's see, I'm gonna put a little bit more so it will be more dramatic, hopefully. So now I'm gonna wipe my hand. This time, I'm going to use, this is just regular hand soap. Somebody asks like, can I use bar soap? Yes, you can use bar soap as long as it kind of like cover your finger with soap. Okay, so now your hands full of soap. Now I'm gonna do the same thing and hopefully let's do slow motion. Let's do it, let's see. You see that? Is it like magic? If I put my finger, the pepper is kind of like spread and none of them stick. Maybe just a little bit, but it's way cleaner than before.
Right? The pepper's not stick on your hand, yeah, Miss Mel?
Yeah. Okay, so maybe I'm gonna unmute this time. I want to see if anybody can tell us, what do you think, why? Okay. Miss Ashley can unmute.
Okay, so
who wants to try to answer why?
Experience yang sudah coba can raise your hand and then you can tell us, is that the same experience like Miss Melanie had? Okay.
Siapa? Who wants to answer?
Who wants to share? Evan, how about Evan?
Foam soap, yes, foam soap can also work. To try that.
Oh, Joanne still sticking, Miss.
Ah, okay. Make sure your soap is covering your hand. Put a lot of soap.
You need to put a lot of soap all over your hands. Yeah. Peppernya not sticking.
Yep.
Okay. Does anyone want to share their experience? How about Richard? Did you already try? Sudah coba?
Can you unmute yourself, Richard?
Richard.
No. Okay.
Yeah, okay. Raise hand. Okay.
Yeah. Go ahead,
yes.
Richard.
Yes, it's almost the same as yours. When I put it in, it just like expanded, and I think I also know why, because this. Wait, can I say that? Can I say why I think it happens?
Of course, yes.
Oh, okay. I think it's because this soap weakens the surface tension of water. So pepper. So like this is water, right? And also when soap enters the water, basically surface tension in the middle of the water just weakens. So pepper wants to go to the edges because the edges has surface tension that is more powerful than the one in the middle, basically.
Good, good, good. Thank you for sharing your opinion. And you prove it when you try it, it happens, right? The pepper spread. Okay, good, good. Anybody else? One more person before I give to Miss Christo to share.
Okay. Anyone?
Ayo, we have 80 kids here. Who else from?
Falco, how about Falco? Are you finished, Falco? Your experience?
Okay, that's okay. Maybe we'll give
Oh, Falco finished. Okay.
Okay, Falco mau share?
Oke, bisa Sri unmute dulu untuk Falco.
Ya.
Oke. Yeah. Okay, Falco, go ahead.
In my opinion, the virus moves away because the soap is effective against it.
The soap, the pepper is like a germ, huh? And then
Yes.
the soap, yes, the soap is very effective against the germ. That's what you said? Cool, thank you. Okay, now I'm going to back to share my screen and Miss Crystal, should I play the video first or you want to talk first?
Yeah, I think we can play the video first. I just want to say that it's very impressive that you guys can know how the soap works and how the pepper spread. I'm really impressed.
Cool, yes. Okay, let's try this one first. So let's, again, let me open it bigger and.
Can I please have the wipes? Who's got the wipes? There's schmutz on my chair. Hello and welcome back to Homeroom News. Our top story today is washing your hands with soap. 10 out of 10 doctors recommend it, and not just because dirty hands are gross. Soap kills germs, including this little menace, the new coronavirus. Here to explain just how soap works is our science reporter, Rita.
Thanks, Tim. Great to be here.
You know, it's funny. Before I read it off the cue card, I didn't know soap killed germs. I thought it just kind of washed them away.
Well, you're not entirely wrong. Soap is a surfactant. It makes surfaces slippery so dirt and germs can be rinsed away. To understand why, we have to go down to the microscopic level. Each particle of soap has a hydrophilic head, which is attracted to water, and a hydrophobic tail, which is repelled by it. When you lather up, those particles spring into action. The tails try to face away from the water, while the heads try to face towards it. They form tiny beads, with the tails pointing in so they're not exposed to water. Some of these beads happen to form around material on your skin, dirt, germs, whatever. Since those water-loving heads are pointing out, running water pulls the beads away. That's why soap is so good at cleaning things.
Fascinating. But what gives soap its killer rep with germs?
Well, soap also destroys membranes. That's a flexible outer layer found on bacteria and certain kinds of viruses. The coronavirus is one of these. Membranes are made up of particles similar to those in soap. One end is hydrophobic and the other is hydrophilic. In the presence of water, a soap particle acts like a knife flying into this structure. The hydrophobic tail wedges itself into the membrane and splits it open. That destroys the virus's ability to infect your cells. As for bacteria, they drop dead without a membrane. All of this takes a bit of time, though. You should wash for 20 seconds before rinsing with water.
Our cells movie says that the cells in our body have a similar membrane.
Okay, I'm not gonna play until the end because that's basically the explanation why soap is good against dirt and virus too. Miss Crystal, go ahead. You can continue.
Yeah, I just want to say that what a good reminder for us to wash our hands frequently, especially during this pandemic. We want to keep the virus away from ourselves. And I think previously Richard also said something about the surface tension, and you were totally right. Water molecules like to be with each other, but when you put soap in it, obviously the surface tension got disrupted, and so you can see that the pepper were spread out. And so, yeah, so that's definitely how it works with the experiment.
Good, thank you. So now I want to introduce Miss Crystal. Go ahead, tell us about yourself.
Sure. Yeah. Hi, everyone. So good to see you all. My name is Christo, and I am a postdoctoral researcher at Stanford University. And what that means basically is that I do science experiments for a living. My current area of study is in infectious disease. I study about harmful bacteria that gets into people's blood and make them very sick. And basically, what I want to achieve with my research is to detect these bacteria as soon as possible. Yeah, someone say, is it like Corona? It's a little bit like Corona, but Corona is a virus, but I actually study bacteria. So yeah, so I think we can go to next slide. So my journey in STEM actually started back when I was in Indonesia. So as Miss Melanie told everyone before, I'm actually currently in California, USA. But I did my junior and senior high school in IPK. So both my SMP and SMA. And then, so this is really when I first started to get really excited and interested in science. I remembered I studied biology and chemistry. I really enjoyed the experiments, the lab classes. I really enjoy learning about living systems, how our body works. And so when I finished high school, I asked myself, what should I study next? And that's when I decided to go to Australia and pursue my undergraduate training, so S1. So this is where I started to learn about medicinal chemistry. So what that means is I studied about how medicine works in our body and how to design new medicines. And at the end of my undergraduate degree, I actually get to do a one-year research program, which got me even more excited about science. And so you can see in the photo on the left is the day when I graduated with my friends. And then after that, long story short, after my graduation, I asked myself again, what should I do next? And while I was applying for jobs, I was firstly intending to work in pharmaceutical companies. But at the same time, I was also applying for a scholarship for a PhD program. And thankfully, I did receive the scholarship. And so I continued my education and did another 3.5 years of doctorate training in chemistry. And I thoroughly loved my time at the university. I get to do a lot of experiments, learn a lot of things about our body, about medicine, about various diseases. And so by the end of the program, I graduated in 2019. You see my graduation picture on the right-hand side of your screen there. And after that, I basically said, you know what? I want to do more science. I want to, work at the university and work in a lab and, study as much as I can and basically do experiments for a living.
Yeah, that is a very good story. So let me ask you, I mean, most of the kids here, I think they are either in elementary school or maybe middle school, right? So they still have a long time, maybe not too much, but yeah, they still have a few more years before they go to university. But here, you guys listen to Miss Christo. So in university, how many years did you learn in university from S1 to PhD?
Yeah, so I did my undergraduate degree in Australia, and in Australia, S1 or undergraduate degree is usually 3 years. But if you do a science program, you can do it for 4 years, and the last year is basically a research program. So it's like 1 year of experience just in the lab doing experiments, and so that's how it goes.
So you actually do stuff, right? Instead of studying.
Yeah, you work on a project like so a science project, and then you work on it for a year, and then at the end of that you write a report and you can graduate. And so what is also unique in Australia is that once you finish that program, so you can go from undergraduate, which is S1, straight to S3, which is PhD. And in some countries, you can do master's degree in between. But in Australia, you don't really need to do masters to go into a PhD program. Yeah, so so in this slide, I basically want to share how coding has actually affected my research. And so during my time in Sydney, I was able to work with a startup company who makes this kind of 3D bioprinter. And so if you've heard about 3D printing, this is an application of 3D printing for biology. And so what I just want to share is that now you are with KodeKiddo, you are learning about coding, programming, and this can be really useful in real life. And I actually had the opportunity to use some Python coding during my research in Sydney to make different patterns of hydrogel. And these hydrogels are used to grow cells. And so, yeah, just want to share that with you. Okay, so well, fast forward a few years from my time in Australia, I'm now a postdoctoral researcher at Stanford University. So I arrived in the US, well, a few months before the pandemic. So I get to settle in and learn about the new environment, get to meet new friends. And this is the picture of the building that I see almost every day. You can see me in my lab coat, in my lab, and this is basically what I do every day now, doing research, looking into bacteria using a microscope, and really studying about how they can infect us and how we can protect ourselves from them.
Very nice. So if you have questions for Miss Christo, also please use the chat. Don't use the chat for chatting amongst yourself. Somebody's gonna have a birthday soon, I know.
Oh, that's nice.
Yeah. Yeah, so Miss Christo mentioned even though she study biology and chemistry, but the technology part is still very critical, right? You use technology in terms of coding, as well as all of this equipment that you use. It's all using technology. You're not doing like maybe Marie Curie 100 years ago.
Yeah. I think what I want to say is that programming and coding, they're very useful tools actually to help research move forward. Because if you think about it, in the past, when we analyze our data, we do it manually. We have to, type it ourselves, and then we have to look at so many data points and then try to consolidate them ourselves. But actually nowadays with machine learning and programming tools, we can try to analyze data in a very different way. So this is just one example of what something that I did just recently. I look at the shape and the sizes of bacteria and see how they change over time. And usually with just your bare eyes, it's really hard to know when they actually change, what sort of patterns of changes. But with machine learning and programming tools, you can automate this. And that means that you can, do your experiments, upload it in a software machine learning tool, let that tool sort of help you analyze the data. And then while doing that, you can do even more experiments. And so we now actually deal with a lot of big data. So what we mean is like a big data set of, information that is going to be very time consuming if you do it manually, if you look at it manually. But with machine learning, programming tools, we can easily analyze data in a very quick manner. And so that helps move forward our research even more.
Nice. Okay, thank you, Miss Christo. Again, if you guys have questions, Miss Priscilla and Miss Christo still hang around until the end of the webinar, so you can put your question in the chat. In the meantime, let's move forward to the second experiment. And this one, we're gonna put it now because it will take time. So while our ice cream is developing, we're gonna talk some more, including the quiz. Okay, so for this one, we have told you to prepare the ingredient. You need, I'm gonna spotlight my other thing. So this is the material that you need. Make sure you put it next to you. We need milk, we need sugar, we need lots of ice, we need salt, and 2 plastic bags, 1 for the milk and 1 for the ice. Okay, I'll give you maybe 1 minute. If you don't have it ready, go grab it quickly. In the meantime, Miss also going to prepare the one over here. So I'm gonna, okay, you can see my milk in a small plastic bag. And then I have my salt. And I have my ice in a big plastic bag. I have already put some sugar in my milk, so it's sweet. You don't have to put sugar, but usually ice cream is sweet, right? So if you want your ice cream to be sweet, you put sugar, or if you have strawberry milk, it will become strawberry ice cream. Or if you have vanilla, you can also put a drop of vanilla. It's up to you, it's your taste, which one you like. So this is the ice in the big one. And I'm gonna put it. And this is the ice, the milk. So as you can see here, because I just take out my ice from the freezer, it's still all solid, right? The trick here is we're gonna make our own ice cream without ice cream maker, without refrigerator or freezer. Is that magic? No, it's actually science, right? So we're gonna talk about the science later on, but right now, let's focus on making it first. I want to make sure that indeed we can make the ice cream. So what we do is, we put the milk inside the ice. Don't open it, it's still inside the plastic. Just put it in the middle of the ice. What do you think will happen? I shake it, shake it, shake it. Do you think my milk will turn into ice cream right now? Let's check. No, it's still liquid, right? So it doesn't do anything. It's just make it cold. So the magic or the science is gonna be, we're gonna put salt, lots of salt inside the ice. So I put salt on my ice, maybe about half a cup, right? Or 1/3 of a cup. Now I'm gonna put the bag again inside in the middle of the ice. And then I'm gonna shake it again. And we will wait, we will keep it like maybe about 5 minutes. Okay, so you just put it like that. And then if it is too cold, you just put it in a big bowl and leave it there for 5 minutes. Okay, after 5 minutes, we're gonna check it together. What happened to it? You can also see, because since I put the salt, the ice actually melts. The ice melts faster. And that's what we want. So we'll leave it here for 5 minutes. Okay. Any question from you who's doing it at home? Yeah, just keep it there, 5 minutes.
How about sugar, Miss? Grace asking, how about we adding sugar in the ice?
Yeah, you can not in the ice. In the ice, you only put salt.
Oh, only salt, Grace. You cannot use sugar.
You put your sugar in the milk, so your ice cream will be sweet.
Yeah.
Okay. So again, I'm just gonna repeat. Inside the small plastic bag, inside the small plastic bag is just milk and some flavoring And then inside the big plastic bag is your ice and salt. And then we will wait for it for 5 minutes. While waiting for that, so let me go back to sharing my screen. So hopefully this is what we want to see. I'll turn into ice cream, let's see. Okay, I'm gonna skip that one too because this is the explanation of why. So while waiting for that, let's talk a little bit about STEM, right? STEM is an abbreviation. It stands for science, technology, engineering, and math. And this is kind of like all of the subject area that we think are very important for kids to be able to become an active learner instead of just listening. Because most of the time when we talk about STEM, it's actually involved of doing something, right? You're not just reading science book, like Miss Christo says, she's actually going into the lab and then do experiment. Miss Priscilla built something using math, using engineering. So that's why we want to introduce this program to Kiddo STEM, which is in KodeKiddo, mostly what you learn is about the coding, the programming, the software part. But then for Kiddo STEM, the class is mostly about like doing an actual experiment. And of course, there will be some explanation of why it happens, the science behind it. But to make it fun, we just not read about the theory, but we actually do it. Okay. So our approach is, as I mentioned, is going to use design thinking and hands-on. I really like this motto from MIT, a big university here in the US. The motto is mens et manus, which means mind and hand. So they want to train the student, not just the brain, but also to make it, to use your hand, to actually get dirty, to get experience with making stuff. So that's why we, in Kiddo STEM, that's the combination that we want to do. It will be project. The project, hopefully if we open in person, it's going to be group project. But if it is still online like this, of course, you have to do it by yourself at home. But through live Zoom meeting, we can also share about the result and question and stuff like that. And the materials are provided by Kiddo STEM. So you guys don't need to ask your parents to go to the market just to buy like one wire or something like that. That will be part of the program. The first event that we're gonna have is during this holiday program. We will have few topics related to Kiddo STEM. One is called Kitchen Chemistry Lab, which is most of the project is related to chemistry, chemical reaction, using regular stuff you can find at home. And then there's another topic called Toy Factory, make your own toys, but at the same time, you learn about mechanical engineering, you learn about physics, right? For this project. And then another topic is camping adventure. Who doesn't like camping? Everybody loves camping, right? Go to the outdoor and then survive in the wild. But this one, we are pretending that we're going to go camping. So we do all of this experiment, how to make your own torch, how to make oven if you don't have electricity, right? So those kind of experiment, we're going to cover it in this topic. And then the last one is space exploration. This one, I don't know if you heard about the big news a few months ago. It was Mars rover. Another rover was successfully landing in Mars. And that's part of a big NASA project to send human to Mars. But now we tested with sending robot first without human. And then hopefully in the next few years, maybe your generation, you will see human running around in Mars. Yeah, so those are some of the topics that we are going to have for the holiday program in June, July. This one we have the level and then the registration link. Okay, so let's see our ice cream. Anybody want to, no, Miss, anybody want to show your result, your ice cream? Did it work or not? Let me check mine too. You see that? Okay, maybe I should, okay, look at that. It starts to get solid. It's not liquid like milk anymore. You see that? Now it becomes like crystallized. I know it's not as smooth as ice cream that you buy in the store because this is again a homemade ice cream, but see, it's solid now. And I can even eat it. Yay! What about you? Anybody want to show it on the screen? Your ice cream? Did it work?
Yeah. Is anyone here successful making ice cream, or you want to open ice cream parlor maybe at home? Okay. Richard, are you successful making ice cream? No? Oh, okay. How about Ray?
Okay, why? We can do some trial and error and see why it wasn't successful for you.
Okay, Vanessa said it's still a liquid.
Oh, it's still a liquid. Okay. One tip is, if you think it's still a liquid, maybe you need to put more salt into your ice so the ice will melt faster. When the ice melts,
okay.
Because when the ice melts, the ice actually taking some heat from your milk. And what happens if you take some heat from a liquid? The liquid will turn into solid, right? The liquid will be frozen. So that's what we want. We want the ice to melt fast. Okay, so now let's see.
I guess everyone problems the same, is still liquid.
Still liquid. Okay, we can wait for, oh, mine is solid. See, Joanne say mine is solid. Joanne, can you show it on the screen? Let me highlight you.
Okay, this one, Sandy Ganga also said that mine becomes solid. Oh, do you want
okay.
Your result?
Yeah, Joanne first probably. Joanne, where are you? Ah, look at that. Yeah, see?
Okay.
That's very good. So what did you do, Joanne? You can speak. What did you do?
I put a lot of salt into the ice, and I just mixed it until it's melting. And then when I checked it again, it's solid.
Ah, okay. Did you have to squeeze your ice or just leave it in the bowl?
And then leave it in the bowl.
Okay, good. Yeah, so that works. Who else, Miss Asri? Tadi yang bisa?
Sandy. I guess there's the name Sandy.
Sandy Ganga. Okay.
Yes, Sandy Ganga. Ini berhasil.
Okay, Sandy.
Okay, Sandy, do you want to show? Yeah. Your successful experience making ice cream?
Sandy nggak pakai video soalnya.
Iya, okay.
Okay, good.
So, Anggito. Hi, Anggito. Do you want to show us about your ice cream? Okay, Anggito. Where's Anggito? Yeah,
yeah.
okay. Okay, go ahead.
Turn on your video if you want to show it to us.
You need to turn on your video, Anggito. Okay, where's Anggito? Hi, yeah, okay, Miss.
Okay, berhasil. Okay, yeah, that's okay then. Oh yeah, look at that, Anggito. Okay, let me do it one more time. I will spotlight you so we can see it. There. Yes. Do you use just regular milk or you put some sugar inside? Pakai gula di dalamnya. We cannot really hear you. Yeah, but we can see. It is really solid, yeah? Yay. So this is a good trick. You can make your own ice cream. If it is too hot at home and you want to eat something sweet. Okay, good. Thank you. So let me ask you a challenge then. Who can explain why it happened? Okay, so maybe I ask an easier question first. We have, a lot of people listen. So ice, water turn into ice turn into water, right? On certain temperature. What is the temperature? It's called a melting point or a freezing point. What is the temperature? What is the melting point or freezing point for water and ice? Who's raising hand, Miss Asri? Okay, Richard. What is it, Richard? Collins and Mika. Bisa unmute sendiri nggak sih mereka? Yeah, Richard want to answer. Okay, Richard, unmute.
Okay. So the melting point of water is 0 Celsius usually, but sometimes it changes depending on like the elevation. But if usually if the water is less than 0 Celsius, the temperature usually it is ice, and if it's more, it is water. Usually like that.
Yes, very good. Yes, that's correct. Now, let me hear from Collins. Collins, you want to say something?
The freezing point of water is when the ice is colder than the water, maybe?
When the water turn into ice, that's called freezing point. Yes.
Yeah.
Yeah. Yes, and Richard is correct too, that it is 0 degrees Celsius usually. That's right. Who is it? Mika. Mika, want to say something, Mika?
Well, I think how did it become an ice cream? Because the ice and the salt molecules became together. So that's milk and sugar, right? Inside of it.
Yes.
So milk is a liquid and sugar is hard. Hard food, I think. So the molecule of the sugar got to the salt. It made it melt.
And it make it solid, you mean?
And it made it liquidly solid. So the ice molecules goes to the plastic. Wait, no. I think the cream mixture detects the Celsius around their corners.
Okay, but
around the corners into making it to freeze and solid.
It's a good hypothesis. It's called hypothesis. It's the same as the fancy word for guess. It's a good guess. You say that because of this milk and sugar, but I'm gonna challenge you because for me, I didn't put sugar in my ice cream. I didn't put sugar. This is only milk, and it still turns solid. So it's not because of the sugar. So let's see. Okay, let's watch this one. There is a good video to explain why.
Back together. When we increase the temperature of a substance,
I'm going to rewind a little bit. Okay.
Solid state, its molecule liquid begins. When a substance is in a solid, what a melting point is and what happens during melting. The melting point of a substance is the temperature at which the change in state from a solid to a liquid begins. When a substance is in a solid state, its molecules are tightly packed together. When we increase the temperature of a substance, we're adding energy in the form of heat into that substance. Once the amount of energy added to our substance equals the substance's melting point, the molecules with enough energy begin to spread apart and transition from a solid state to a liquid state. If this level of energy is not maintained, and the substance is allowed to cool or lose enough energy equal to its freezing point, it will gradually revert back to a solid state. When we add salt or sodium chloride into our ice, it separates into sodium and chloride ions. These additional particles in our mixture disrupt the ability of our ice to freeze. The more salt we add, the more it affects the freezing and melting point of our ice. This change in melting point forces our ice to begin absorbing energy from its surroundings and causing it to melt at a much lower temperature than normal. But where is the ice going to get the energy it needs to melt? Our ice pulls the energy it requires to melt from our cream mixture and the surrounding environment.
You see that? Because the ice needs more energy, it pulls the energy or the heat. Heat is an energy, right? To pull it from your ice cream.
As our ice gains energy from the warm cream and gradually changes state from the solid to liquid, the cream is losing energy and gradually changing state from a liquid to a solid. Once our cream mixture has lost enough energy, it completes its transition from a liquid to a solid, and you now have tasty ice cream.
Yeah, that's how it looks like, right? Your liquid milk turned into solid, which is what we call ice cream. Okay, cool. So let's see. Now it's 8:07. Okay, anybody has question about the second experiment? It's okay if it wasn't successful this time. Okay, Michael Rossi has question. Yes. Yeah.
Is ice cream mixed because of the salt or the milk?
Ice cream melt. Sorry.
Is the ice cream mixed from the milk or the salt?
Oh, the salt makes the ice. The salt makes the ice lower the temperature. So then it is taking the heat from your milk. Since the milk was liquid, now if you take the heat from the liquid turns into solid. And that's why your milk turns into ice cream. If you don't put salt, your ice just stay as ice, and it doesn't take a lot of energy from your milk. So your milk keeps liquid. That's why we add salt to help the process, to lower this temperature, to lower the melting point of the ice. Good question, Michael. Anybody else? Fasta Bika, mind working. Okay. Fasta Bika mau share? Show your, let me unmute you. Okay, Fasta Bika. And if you have your video on, you can share it also on the screen.
Wait.
Yeah.
I still look it. It's there's more liquid, but some
Okay.
is some
turn into solid. Okay. Can you show it on the video, or you cannot turn on your video?
Wait.
Okay.
Miss, but some is still liquid lah.
Ya nggak apa-apa, kan namanya juga eksperimen, jadi but it's a good progress, right? Ada It's
Okay.
going to that.
Also.
Okay, yeah, I know. Some kids say that ice cream didn't work. Yeah, it is part of the experiment. Sometimes it didn't work, and you have to try it again.
Wait, yeah.
Okay.
Fasto Bika already starting.
Okay.
Video.
I will put spotlight. Look at that. Okay, so maybe that's also another tips for you who try it at home later. Don't put too much milk, because if you put too much, it will take too long as well to make it solid, right? So I think that's a good size. Yes, about that. See, it's partially frozen. Cool. Thank you. Okay, so now let's, as I mentioned, we're gonna do a quiz. And the quiz that we're gonna do is about electricity. So the way that we do this is we are going to, I will put the link in the chat. And you guys just click that link and click join and put your name. After everybody join, I will start and you can just start answering the question in that quizzes platform. Yeah. Put your real name so we know who, especially if you win. Okay. Yep. I see Richard, Joshua, Clifton, Joanne, Collins. Okay, even the presenter, you can join too. Okay. Yep. One more minute so that everybody get a chance to put your name. Okay, I think most of you are there. So I'm gonna start. You can still joining. I'm just gonna start so we can start with the first question. Yeah, okay. I started, so you should be able to see the question and start answering. Remember, there is also a speed component. So if you answer it faster, you get more points. But if you answer it wrong, later on, sometimes you get a chance to redo. There's a redemption point. Bisa ulang lagi, terus jawab lagi. Some of the question, we haven't talked about it in detail in today's presentation about electricity. So I can understand if you have no idea, then just guess. But maybe if you have learned something from your school or from outside, then yeah, of course, you can use your knowledge. I see that number one so far is Leonard, followed by Richard. Oh, Richard is number one now, Leonard, Clifton, Evan, and Chris. Joanne suddenly shoot up to number 3. And there's about 13 questions, so. Nice. Keep going. The top 5 right now is Leonard, Richard, Damien, Diva, and Chris. But don't give up because it is still possible you catch up if you answer more correctly. Okay, so far Richard is still number 1. And Leonard, it seems Leonard is finished, Leonard. Followed by Diva, followed by Chris and Damien. Wow, Chris suddenly shoot up to number 2. And Grace is number 3 now. Richard has 7 streaks, meaning that you answer 7 questions in a row without any mistake. 8 streaks, good job. Number 1 so far is Richard. Number 2 so far is Chris, followed by Grace, followed by Clifton and Sandy. M. Adnan suddenly shoot to number 3. And Clifton now number 3, okay? Sandy Ganga, Damien, wow. Sandy Ganga is number 2 now. Number 3 is Chris. Okay. Seems like a lot of kids are finished. So 1 more minute. Who is just shoot up? Oh, Damien is racing to number 2. I have a course. Okay, yeah. If you have to go, you feel free to go. I'm gonna stop this quiz soon. Okay, I think we have our top 3. So I'm gonna stop this quiz and let's see. Number 1 is Richard, number 2 is Damien, and number 3 is Joanne. Good job. Okay. Yes, we answered about 13 questions about electricity, and of course we can discuss about it, but since we don't have enough time, let me go back to my slide. So we actually have finished with the content, what we want to share. I just want to remind you, if you enjoy this kind of class, then ask your parents to check out our website or go to this registration link. Miss Asri, you can put it in the chat, bit.ly.
Okay.
Yep. And right now we're gonna open just for maybe 2 minutes for question and answer. If you still have any question or any comments, you can unmute yourself. I'll let you to unmute. You can unmute yourself and you can speak. Maybe if you have specific question about electrical engineering to Miss Priscilla, or...
Can we replay it?
Can we what? What is it, Nika?
Can we have to play the game though, the quizzes game, because I wasn't, because
You didn't join?
yeah.
Oh. What about this? We'll do Q&A first. At the end, I can replay for the one who hasn't done it. Who wants to stick? If you want to stick around, I will replay it one more time. But let me hear from other first. If you have, you can unmute if you have question. This is your chance. Kalau mau bertanyanya pakai bahasa Indonesia juga nggak apa-apa. Semua di sini bisa bahasa Indonesia juga. Jadi silakan jangan malu-malu. Salah satu kriteria jadi scientist adalah curiosity, right? Rasa ingin tahu. Itu yang paling penting. Jadi di sini juga Miss ingin dengar dong dari kalian. Kalau kalian pasti ada pertanyaan, ayo jangan malu-malu. Karena itu indikasi bahwa kalian juga mau berpikir dan ingin tahu. Richard silakan bisa unmute kok.
Okay. How many like experiments do we get for like the 500,000 one before?
Oh, okay. For the program itself, for each team, we're gonna have 4 experiments.
Oh, okay.
And this is for 3 days. The class is 3 days. And this also include the material. So we will actually mail the material to your house. Yes. Any other question? Oke, Miss Priscilla atau Miss Crystal ada lagi yang mau ditambahkan? Oke, kalau tidak ada, terima kasih. I would like to thank our presenters. The one in US is actually almost 9 o'clock at night. The one in Australia is I think about 1 o'clock maybe, 1 p.m. Yeah. Thank you so much for spending your day with these kids. And thank you for you kids who also spend your Saturday with us. I hope to see you again, either in KodeKiddo or Kiddo STEM. If you have questions, make sure your parents take down this number or email, or just check our website. And I can start the quiz again if you want to hang out and do the quiz. Let me see, give me a second. If not, feel free to leave the Zoom. Thank you.
Okay, thanks everyone.
Yes.
Good to see you.
Hi, Miss. Thank you, Miss.
Yes, thank you.
So,
Bye. If you want to do the quiz, I will put it in the chat. It's the same one, so only for the one who hasn't done it. Bye. Yeah, if you want to do the quiz, yes, that's the link. Click that link again.